Alright, so now let's look at the inner boundary condition. And I'm gonna use... Did I already use blue? Yeah, I've already used blue. Alright, so I'll be using green then. So now let's look at the inner boundary condition. So there are a couple of different inner boundary conditions, which I will be listing down just in a moment. So we have constant rate production, and this can come with skin and also with well-bore storage, and also both and also none. So from here we have just constant rate production without skin and well-bore storage. You also have constant rate production with skin without well-bore storage. You have constant rate production without skin and with well-bore storage, and finally constant rate production with both skin and well-bore storage. Okay, so for this case, we'll just consider the first part. Okay, this really... Alright, we also have another possibility, which is constant pressure production. But as I've mentioned in the previous videos where I've derived the dimensionless diffusivity equation, we are only looking at this case for now, constant rate production, because for constant pressure production we actually have a different definition for the dimensionless pressure. Okay, so we'll be looking at the constant rate production condition. Okay, so for this we'll need to remind ourselves of Darcy's law, which is QB is equal to Ka over alpha 1 mu dou P over dou R. And we need to recall that this is occurring at the, well, because this is the inner boundary condition. So, and also our area is equal to 2 pi RH. So this can be rewritten as, okay, let's do this in my head quickly. We have 2 pi over alpha 1 KH over mu R sub W dou P over dou R, and this is happening at RW. Okay, and alpha 1 is just a constant for conversion to field units. Okay, so now let's rearrange this a little bit. We have R sub W dou P over dou R at R sub W. This is equal to QB alpha 1 mu over, what was it, 2 pi kh? Yeah, over 2 pi kh. Now what we're going to do is we actually have two non-dimensionless terms here, dou P and dou R. So we're going to substitute the dimensionless definitions for those, and we'll get this bad boy over here. Now I'm not gonna break this up like I have in the previous steps. That's just time consuming for this video, but you can easily show from here, from this step, that if we simplify this, we will get dou P sub D over dou R sub D is equal to negative KH over 141.2 QB mu multiplied by QB mu alpha 1 2 pi KH. And here we'll introduce the fact that alpha 1 is equal to 141.2 multiplied by 2 pi. So we can rewrite this as negative kh over 141.2 qb mu qb mu here 141.2 times 2 pi all over 2 pi kh. Now we can make some simplifications. 2 pi's cancel out, kh cancel out, qb mu's cancel out, and 141.2 141.2 cancel out. Finally, we're left with dou p sub d over dou r sub d is equal to negative 1. Oh, and there's a r sub w here. Yeah, I think I forgot to. Did I forget to do that? No, I don't think so. Yeah, this would be an r sub w. Okay, so finally we can rewrite this as r sub d dou p sub d over dou r sub d. So now, what's the value of the dimensionless radius at rw? So rd is equal to r at rw. Therefore, r sub d at r equals rw is equal to rw over rw, which is equal just to 1. Okay, and this is equal to 1. Alright, and this is our inner boundary condition. And again, I'm not doing this for the cases for skin and wellbore storage in this video. We'll treat those in a separate video. Alright, so that's it for this video. If you liked, please leave a like, comment, and subscribe, and click the bell notification for icons. Thank you once again for watching, and stay tuned for more. Bye! Hey guys, a quick correction on the derivation just now. So in this derivation, this r sub w here should not be here anymore. Or sorry, not this one, but this one, starting from this one. Reason being is because when you break apart this derivative, we would end up taking out a factor of 1 over rw, and this would cancel with the rw over here. So this is cancelled, this is removed, this is not present, and yeah, neither is this thing over here. Okay, so I'll rewrite the inner boundary condition, and it comes to dou p sub d over dou r sub d evaluated at r sub d equals 1 is equal to negative 1. Okay, alright, that's it. Thank you, and see you again.